Now factorize this expression, x square plus x plus 1. The coefficient of x here is 1. So we need to find two numbers whose product is 1 and sum is 1. We know that 1 is equal to 1 into 1. Also 1 plus 1 is equal to 2. But 2 is not equal to this. So this is the only possibility here. But this does not give us the two numbers which we require. So we cannot factorize this expression by splitting the middle term. So all expressions of this form cannot be factorized by splitting the middle term. The question is, how do we find which expression can be factorized by splitting the middle term and which expression cannot be? One way is obviously by trial and error, but then consider this expression. Now we need to check whether it can be factorized by splitting the middle term or not. So we need to find the two numbers which add up to 15 and give the product as 60. These are the possibilities. After considering so many possibilities, we find that this expression cannot be factorized by splitting the middle term. So this is the disadvantage of using trial and error. Is there a better, simpler and a faster way of finding out whether an expression can be factorized by splitting the middle term or not? Well, yes, there is a more mathematical and a logical method from which we can find whether an expression can be factorized by splitting the middle term or not. What is that? Compare this to ax square plus bx plus c. So this is the general form of this expression. Here a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Now find b square minus 4ac. So we need to calculate b square minus 4ac. If it is a perfect square, then this expression can be factorized by splitting the middle term. If not, then this expression cannot be factorized by splitting the middle term. So let us find b square minus 4ac for this expression. b is equal to 15. 15 square minus 4. A is equal to 1. And c is equal to 60. So we need to calculate this for this expression. 15 square is 225. 4 into 60 is 240. 225 minus 240 gives us negative 15. And negative numbers can never be perfect squares. So this is not a perfect square. Hence, we can conclude that this expression cannot be factorized by splitting the middle term. So this is a simpler way. In this case, it is a simpler way to find whether this expression can be factorized by splitting the middle term or not. But then there can be expressions where trial and error is a simpler and faster way to find whether it can be factorized or not. For example, x square plus x plus 1. When we had this expression, trial and error would have been a simpler and a faster method to check whether it can be factorized or not. So it's up to you. You can use any of the methods. Now check whether the following expression can be factorized by splitting the middle term or not. So we have learned the rule and we compare it to ax square plus bx plus c. Find b square minus 4ac. b is negative 5. 4. A is equal to 2. C is equal to negative 6. So calculate this. Negative 5 whole square is 25. Negative gives us positive. 4 into 2 is 8. 8 into 6 is 48. Now add it, we get 73. So 73 is a perfect square or not? No. 73 is not a perfect square. Hence this expression cannot be factorized by using the middle by splitting the middle term.